Okay, hello everybody. Now we want to show an example of how to use the Ripple Down rules with a relational example. Basically, what I mean is a bunch of classes that are related to each other and have relationships with each other. And the example that we are gonna use now is this simple model. We have a physical object which has a string name and a list of objects that are also physical object. We have the part class, which is itself a physical object. And finally, we have the robot class, which also is a physical object, but has additionally parts as physical objects that are part of it, right? And what we want, basically, we want to create a robot object from this, an instance of robot, and we want to query, for example, the contained objects of that robot we created. And we want to fit Ripple Down rules to basically tell us at any moment what are the contained objects of our robot. So let's see how to do that. So in this example, I create a simple robot, a simple system where we have three parts, A, B, and C. We have a robot called PR2, and it has one part, which is part A, and part A contains objects which are just part B, and part B contains part C. Optionally, you can allow for GUI to pop up to use the build down rules using the GUI interface. Otherwise, you can just use the IPython interface if you don't want that. And then we initialize our build down rules model. Usually, you would just want to use the general RDR because it is the most sophisticated and fits for all purposes. This takes basically two main arguments, which are the save directory where you want to save your model and the model name. If the model is already there, it will automatically load it. If not, it will create a new one. Then once we have our data model, we have our model, RDR model, now we create our query. So here we want to query about the contained objects attribute of the robot. So the robot here is our case. So any object that we are querying something about, we call the case. Thus, we have this a case query. So our case is the robot, and we are querying the contained objects of the robot. So usually you would have, you are not querying the object value itself. You are querying some information about the object, which is the case, right? And here you specify the output types. Basically the types of contained objects. What are the output types there? Usually here we ignore the container. So if it's a list, we just say physical object because this is implicitly assumed when setting the mutually exclusive value to false. Mutually exclusive value basically says that our attribute here is can have multiple values. Thus, it will be like a list or a set anyway. So it's not just one value, like true or false. So it cannot be true and false at the same time. So it can have multiple possible values at the same time, right? So we can have multiple contained objects at the same time. So we set the mutually exclusive to false because our attribute is not mutually exclusive. And we just set the core attribute of the core type of this. So what's the type of an element of this set or an element of this list, which is the physical object in our case. And then we simply call fit case from our created model to the case query we just created. And at this point, when you run this code, the model will prompt you with the interface and prompt you for answering this query, because if this is an empty model, it has no rules, it cannot answer this query. So it will ask you, please give me a way to answer this query, right? So if we run this, we will see here an interface. We have three main panels. We have the left panel, the middle panel, and the right panel. The left panel just is a view of the current object, which you can explore like that, and you can see on the right side that it shows you the object diagram, the class diagram of the current case that we have. So you see that the robot has three attributes, contained objects, etc., etc., etc. And in the middle, basically in the middle, we have the title, which is the question that Dribble Down Rules is asking you as the expert. So it's asking you to give possible values for robot.contained objects of type physical object. We will see that there is already currently a value, because I have already wrote a rule for that. And we can see if you do like press rule tree, you would see that there is a rule, and this rule has actually fired with a query related value. But let's start from scratch. Let's remove the rule model that I have already, which is basically stored in the same directory of my, so you would see this is what's generated by the Dribble Down Rules. So I will delete this model completely, and then I would run again. It should now give an empty result. So you see it's telling me that the current value for robot.contained objects of the physical object is list empty. So now we have no rules, we have no conclusion whatsoever for this query. And here in this IPython interface, you can explore the case that you have. So if you write case, you would see that you have a robot which have these attributes. You can say like case dot name, you can see the name, case dot parts, and etc. So right, and you can press the current value button. You can say, okay, what's the current value for the attribute that we are querying, and it will give you like, it's an empty list. You can also do that yourself by saying case dot contained objects, right? You also have tab completion there, so you can use that. So now our goal is to answer the query. I would say one possible answer, given the case that we have here, what does the robot contain? I would say if A is part of the robot and A contains B, then I would say logically that the robot must contain B. So I would say basically that the contained objects of my parts are also my contained objects. So to do that, you press the edit button here. You'll see that you are given a file that pops up in your editor. Usually if you have PyCharm will be opened. If not, it will look for VS Code. If not, it will look for Codeserva. But you can also modify how which editor is being opened using RDR command editor in your bash RC, an environment variable. So we have here this template that got created for us and telling us to edit the code here, write code here. Thank you, Mr. Computer. So it's basically asking us to give a possible value for robot.contained objects, which should be of type list of physical object. And we are given a case as input. This case is of type robot. So let's write our conclusion here. I would say contained objects is an empty list. Yes, thank you, Mr. AI. So I'll just remove that. So it says basically for part in case.parts, I add the contained objects of my parts to be the contained objects of myself. And then in the end, I just return that. And then we go back to our GUI and then we press the load button. Now you see that the load button, what it does is it loads the function that we just wrote, that we just filled out, right? And this is the name of the function. And if you write the name here and you tap complete, you will see that it already recognizes it as part of your scope of the IPython interface. So if you give this the case, we see that the output is correct, which is part B, which is what part A contained, right? So that is correct. Now, if you're happy with this rule, you can just press accept and you will get another prompt. So a rule contains two parts. It contains conditions and it contains conclusion. So we just now wrote the conclusion of the rule, and now it's asking us for the conditions. The conditions are basically asking when is it possible or when is it reasonable to evaluate the rule that we have. One possible thing is to say that my robot has parts. So if it has no parts, it's meaningless to evaluate our rule, right? So I would just press the edit here. I would write return length of case of parts is greater than 0. Okay, so we have some parts in our robot, okay? And then we go back to our GUI, press the load button again, make sure that our conditions are what we expect. So it is true for our case. Then if we are happy, we press the accept button. Now we are not prompted anymore because we have answered our query, we have fitted a rule for it, and actually if we run it again, we will see that it already gives an output not empty anymore, which gives us part B. And you will see that the robot now has some contained objects, right? So, which is part B. And if you press the rule tree, you would find that there is already a rule there, and it fired, and it is the reason why we have an output currently in contained objects, right? Okay. So if you have no further rules to write for this, no further conclusions, no further contained objects, you just press accept, and that's it. And you see here we just get the result by classifying the robot. So the classifier just takes the robot instance and gives you a result, and you can assert that this result is what you expect. So that's it for this tutorial, and thank you for listening. See you in the next one.